What's going on, guys? It's me, Mikey Pipes. So last week or a week before that, we were here doing annual maintenance on this Generac 20 kW air-cooled whole house automatic standby generator. And when we did the maintenance, we saw that the battery was all jacked up. Here's that battery. So she's leaking. She's a leaker, right? So nonetheless, we are back with a brand new battery. But also, we're here. This compressor is really making a horrible sound. Horrible sound. So before we left, I say, listen, we need to replace the battery. When we come back, it would be a good idea to do general maintenance and a tune-up on your air conditioning systems. We have 1, 2, 3, 4, 5 systems. Five systems. And in case you're wondering, Mikey Pipes, like, what's up with the 5 systems for a house? I'm like, well, this is not any house. This is what we call a Taj Mahal. We have an excess of 7,500 square feet in an all-brick structure. And this is just the corner. That's just the garage wing, which dips into there. But we have a full 2,500 square foot basement. We have not one floor, it's not 2 floors, but the third floor, basically like an attic. But let me tell you something, up in the third floor attic, we have 5 bedrooms and 3 bathrooms. There's the other one just kicked on as well. So I'm going to change the battery out, and we're going to focus our attention of this video on this carrier and see what's going on with that compressor. We'll take a look at the pressures. Something's wrong going inside that compressor, and we may have to do a warranty exchange on it. So let's see what's going on. All right, so I got my battery removed. The terminals don't look terrible, but we do have leakage coming from the case of the battery. So that's the reason why we're replacing it. Before I put the new battery on, I'm going to take a wire brush and I'm going to clean the inside of these LED terminals. It gives them nice and clean. And also going to take a wire brush and scrape off the coating off the new battery terminals right there. So let's do that first. Slide this back in and we'll fire her up. Well, she finally turned off that compressor. That condensing it seems definitely seen better days. Okay, so we have a nice clean surface there. Let's do the neutral, the negative terminal. I just called it neutral, didn't I? Yep, the negative terminal. And my 3/4 inch quarter turn brush really does a great job getting in there. So that's good as well. Let's just get some of the extra little cocky off of here. Okay, like that. Nice and clean. And the other one as well, since... Okay, good. Let's get the battery in place. All right, battery is in. There it is. Let's... these doors. Someone made a comment that the... There we go. Let's fire up. All right, we're running. Now we're cooking with gas. All right, so we're gonna bang out maintenance on all these at the same time. I got all the covers off. There's my condenser 1. We'll call this condenser 2. Number 3. Number 4 has been worked on several times, obviously, and no one even bothered to put her back in the right way because she's busted out right there. And condenser number 5. They all look like their original components, OEM parts, except for this condenser with the hard start and the dual capacitor there. It's quite evident there hasn't been really any recent maintenance on any of these systems. So, and this one's also making that horrible noise. A little careless there with putting in the wiring into the I guess you want to say the holder. I don't know, I want to call that a holder or track. Well, it looks like a piece of wire mold, but typical of a York. You know, I like to use a piece of 3/4 liquid tight and go from there to there, and when I replace a condenser fan motor. But here, you know, this one has been neglected to be put back right. We're gonna start with that one. I'm gonna check my capacitor. I'm gonna check my coil resistance on the contactor, and we're gonna do 1, 2, 3, 4, and 5. I'm gonna spare you. I'm not gonna do all of them, but I want to focus on the noise from that compressor and also this one. This one I think may be a rattling issue, but that one definitely sounds like something's going funky with the scroll inside the compressor, and I wonder if it's actually doing anything. We'll find out. All right, I want to focus my attention on this unit for right now. Off camera, I took my Milwaukee M18 compact air blower. It's like a leaf blower, and I blew out the electrical compartments of this one, 2, 3, 4, and 5. Being careful not to disturb any of the wiring in case there's anything frayed. You want to just be visually observant of your surroundings. System right now is in the off position. There goes that one again. The one in the corner. I want to check my amperage when the compressor turns on at my contactor and see if that has something relevance here. I don't want to condemn this compressor unless it's absolutely necessary. The noise is bothersome to me, but let's see if I can bring this some more life, because I did check the warranty. The homeowner never registered it, so there's only a 5-year warranty, which expired last summer. So let's see what we can do. All right, so I have my clamp-on multimeter on L1 of my contactor terminal, right? I'm gonna push in my contactor with an insulated needle nose pliers, and let's see what our amperage jumps up to. Okay, I was expecting a lot more than that. It only started at 7.5, but it don't sound too healthy, that's for sure. Okay, 8.5, 8.6, 8.7, 8.8. There's definitely some funky stuff going on here. 9 amps. So don't sound too good, that's for sure. All right, so I checked my compressor, which is rated 35.5. It's actually rated a reading 30.1 over 5, actually 4.9. I don't hear nothing in there. Look how my amperage started considerably lower this time with the new hard start by Amrad. Now we're at 6. We started at 5. You saw that for a split second. Now we're 6.5, and surprisingly, the compressor's still making some funky noise in there. My amperage is under 5, under 6, I'm sorry. But we heard it with this capacitor. Now we're at 5.5. I want to see if I put in a hard start and wire that to my CPT terminal. Would I have some better readings, and can I maybe extend the life of this compressor? All right, let me show you what I did and what I used. Let me show you what I used first. I got my Amrad, my 35 over 5, 370/440 dual capacitor. So I used that. And then I broke out my 521 compressor saver. This is kind of like a hard start. You know, it's for scroll or reciprocating compressors. This one is the 1, 2, or 3 ton model. And what's great about this, when you add in my Amrad dual capacitor with my CPT terminal, right? My hard start potential relay is wired to that terminal, right? So if something goes wrong with the compressor or the hard start, right, you're gonna save the life of the equipment, right? So that's why the CPT terminal stands for compressor protection terminal. Something goes wrong with the hard start, it's gonna save the compressor and not give it that oomph that's looking for. You know, the oomph. So my cold for heat is over, as you can see, right? Don't worry, I have the disconnect unplugged. Yeah, I second guessed myself for a second. Let's see what's going on. Let's see how this thing's gonna operate. All right, so let's review. I have that striped yellow wire going to my CPT terminal. I have my blue wire, which is going to my compressor, right? The red wire was coming from the relay, which I mounted. By the way, it says mounted with the mounting tab pointed upwards. I made no reference to the actual, I guess, capacitor, you want to call this. Made no reference to that, so I secured that in the electrical compartment as well. My brown is my fan, and let's see what happens. Let's keep an eye on our startup amperage on my compressor. All right. I was was expecting less. And we had less amperage without the 5-2-1 hard start. And we're at the 6 amps of power right now with it running. And that compressor still don't sound too good, but now we're 5.6, 5.5. Let's see what's going on. Come on, 5.5, 5.6. Should probably be a good idea to test my refrigerant pressures. 5.7 still. All right, I was looking for something a little different. 6 amps, 6.1. Let's check our refrigerant. All right, my refrigerant pressures appear to be a little low. It is 70 degrees outside, and I was taught that when the system is off, those pressures should equal ambient temperature outside. And I doubt it's 60 degrees inside. So I'm going to wager we have a refrigerant issue here. All right, let me make sure my blower's on and turn on the thermostat and see what's going on with this bad boy. All right, this one, my pressures are good. While it was running. That's with it off, 68. 68 degrees on both sides. The system's been off for, I don't know, about 15 minutes. I replaced the dual capacitor on this one. I'm going to dynamically test the dual capacitor with the hard start on this one using the HVAC school underload capacitor tester. We can dynamically test the capacitance of the capacitor while it's running. Let me show you how to do that. Pull up this little drawing right there. You can't miss that. First thing we're going to do, we're going to take a voltage reading between our common and our Herm side. So let's do that real quick. All right, so I have one terminal of my flute multimeter on common, the other one on Herm. I'm dealing with 370, it looks like 300, yeah, let's say 370 volts. So I type that into my underload capacitor tester at 370 volts. Next, we're going to take an amperage reading on that brown wire, which is right there. That's going to our compressor. And we have 7.1. Let's type that into 7.1. And my capacitor, I believe, is rated for 50. If I'm wrong, it's going to tell me. We'll hit that calculate button. And I'm reading 50.91 calculated microfarads. And my dual capacitor is rated for 50. So my compressor side of this is good. Actually, we're 55 over 5. Oh, wrong. We're actually at a 55. Let's calculate that again. And now we are low on that variation because we're 50.91. Let's double check our numbers and make sure we're good. So let's get out of that. All right, 370 voltage across capacitor. Let's go back to our diagram. Voltage across capacitor, we're doing from common to Herm, right? And all right, perfect, I did that right. So that's 370. Let's double check that number. Well, you saw it before, ladies and gentlemen. Now it says 375, 377. Let's clamp that on right there. It's saying 376. Turned off again abruptly. And my amperage was still 7.1. No, we're still under well, we're still within the 5 to 10% range, but we should be replacing this 55 over 5 dual capacitor. We're going to do that right now. All right, so just want to tell you that if you ain't testing, you're guessing. I was here to install a new battery on the Generac, right? And while I was here, 2 weeks ago, we made reference to the noise of the compressor on that one system. We found the noise from another compressor on another system, and now we're here again. And here is one of 4 capacitors that are out of range at this customer's location. 4 of them that we replaced. This was 55 over 5, and yes, it was still within that 5 to 10% of deviation, but I can tell you what, I wouldn't wager against this capacitor dying on one of the future hotter days of the year. Probably the next hot day of the year, because it gets hot in there, it gets used, and guess what? She passed the shake test, but she didn't pass the Mikey Pipes capacitor test. Thank you so much for watching, guys. Until next time, be well, God bless, stay safe.